One of the most useful skills with graphs you can have is the ability to find distance between 2 points. Geometry requires a lot of distance ideas because we're looking at a physical representation of something mathematical. And so distance is kind of a natural thing to want to know when you're using geometry, especially analytic geometry, like with the Cartesian coordinate system here. To find the distance between 2 points, this is maybe surprisingly just the Pythagorean theorem. The distance between the x values is one leg. In this case, I have -3, 2. I'm going to go right over to the other x value, which is right here at +4. And the distance between the y values is the other leg of the triangle. I'm going to go straight up to the point. And so this is the one leg, this is the other leg, and the distance, which is the straight line distance. I'm going to try and draw a straight line. I'm going to actually use line measurement like that. That's the distance of this between these 2 points. If we can find the measurement of that line, then we have the distance. Okay. So to actually find it, we just take the difference of the x values. So we take this x value here is 4 minus this x value here is -3. 4 minus -3 is a plus, and we have 7. So this bottom leg, which I can draw as like a blue here, this blue distance here is 7. Okay, the green distance then, going straight down, this is going to be the y values, subtracting 4 minus, in this case it's going to be -2. 4 minus -2 becomes a plus, we get 6. So this green leg here is 6. To find the distance, all we have to use is a Pythagorean theorem. So if you don't remember, it's going to be a squared plus b squared equals c squared. In this case, we actually rearrange this thing, and I'm going to write the c on the left-hand side, and I'm going to name it capital D for distance. And I'm going to take the square root of both sides. We could say a squared plus b squared. And a is just the difference of the x values. We do x2 minus x1 squared. B is the distance between the y values. y2 minus y1 squared. I should say that it doesn't really matter which way you subtract it. We could say, for instance, these y values here, we could say -2 minus 4. This gives us -6. This doesn't actually mean anything for our problem because distances can never be negative. However, when you use a Pythagorean theorem, you always square the numbers, which means 6 squared and -6 squared both equal 36. So the order at which you subtract it doesn't really quite matter. It does matter though if you're trying to reference the distance of the legs, and that has to be a positive quantity. Distance is never negative. Okay, so we've already found these quantities. The x2 minus x1, this is just the blue, and y2 minus y1 is just the green. So let me write it over here to have a little more room. x2 minus x1 is 7 squared, plus y2 minus y1 is 6 squared. Take a square root of that. 7 squared is 49, 6 squared is 36. 49 plus 36 is 50 plus 35, which is 85. And we ask, can we simplify this? 85 is going to be 5 times 17, I believe. There is no perfect square in there. There's nothing we can break it down, right? You can say 85 is 5 times 17. These are both prime numbers, and there's no pairs. So we really can't simplify this down at all. If you want to know what the actual decimal that representation of that number is, looks like it's 9.22. But the square root of 85 is fine as an answer. That's the distance. Another thing that might be useful, that is useful, is finding the midpoint. It's the exact center between the two endpoints. So in this graph, the midpoint is really just the midpoint of the blue line and the midpoint of the green line. All we're trying to do here is find the exact center, and that's going to be somewhere, I'm going to guess it's like this point right here. My graph, of course, is going to be off a little bit. But that looks to be about right between the middle, between those two endpoints, the 3, -3, -2, and 4, 4. Now to find it, all we have to do is find the midpoints between each of these sides. So we look at the blue line, and we ask, what's halfway up the blue line? Well, let me get a little bit of room here. Halfway up is going to be this whole thing, right? This whole distance here is 7. That's what we found. That means halfway up is going to be 3.5. So 3.5 up from -3, you just go -3 plus 3.5 gives you 0.5, which is right here on the x-axis. And if you look at the green line, right, this distance here is 6. And halfway of that is 3. So we're going to go up 3 units from -2. That gives us 1. And so actually my point wasn't far off. This midpoint would be 0.51. Now there is a formula for this that's actually quite easy to use. All we're really doing here is taking the average between each of the points. That's the same thing as the midpoint. To find the average, we just add up each of the quantities and divide by 2. So the midpoint, use capital M, is the coordinate. It's now a coordinate, so we have to use coordinate notation here. It's really just the average of x1 plus x2 over 2 and y1 plus y2 over 2. And you'll see in our problem we had -3 plus 4 over 2, -2 plus 4 over 2. This gives us just 1 over 2 and 2 over 2, which of course is 0.5, comma 1. So the midpoint formula is quite simple to use. It's just the averages between the x's and the y's. But I wanted to show you the graphical representation and how you can find it that way. Just to recap, the distance formula I wrote right here, but the distance is just the difference between the x values plus the difference between the y values, the difference, not the sum, and the square root of that. This is just Pythagorean theorem. And the midpoint is the average between the x values and the average between the y values. So if I had 2 points like this, -1, 7, and 5, -3, I don't have to graph it. I don't have to know anything about what it looks like. I can find the distance and midpoint quite easily by just plugging them in. x1, y1, x2, y2. And now the distance is going to be the square root x2 minus x1 squared plus y2 minus y1. This becomes a plus. We get 6 squared plus -3 minus 7 is -10 squared. We get 36 plus 100, which is the square root of 136. And we need to simplify this if we can. 136 is 2 times 78. No, 68. It becomes 120 and and 16. So yeah, and this is 2 times 34. This is 2 times 17. And that's where we stop. There is a pair of 2's here, and this 2 remains. So this thing simplifies. This 2 comes on the outside as a 2 on the outside. And then the 2 times 17 remains. So that's going to be 34 on the inside. This is the distance. That's the exact distance. You could find a decimal by just plugging it into your calculator. And the midpoint is just the averages. So we have x1 plus x2, y1 plus y2. This is going to be 4 over 2, which is 2. And this one here is 4 over 2 again, which is 2. So the midpoint is 2, 2. You can think of a circle as all the points of a graph that are a certain distance, the radius, away from a central point. In fact, there really are 2 main features of a circle, the center and the radius. A standard form of the circle is written here, x minus h squared plus y minus k squared equals r squared, which should look familiar. This is actually the same thing as a squared plus b squared equals c squared. It's just Pythagorean theorem again. The point hk is the center of the circle as a coordinate pair. Notice we have negative h and negative k, which means if we have x plus 4 squared, then h is going to equal negative 4. Just keep that in mind. The same thing is true for k. And r is the distance from this center point. In other words, the radius. The important thing to note here is about the radius is that it's squared in the equation. If I have a radius, if I have, I don't know, like x minus 4 squared plus y minus 3 squared equals 16, the radius does not equal 16. The radius equals 4 because 4 squared is 16. Let's look at a circle here. For this circle, I'm going to graph it. You don't really want to graph this by hand because you can just use the software to graph it, but I just want to show you the ideas that can connect to the graphing. First off, the center is at, well, h here is 4 because it's x minus h, and k is negative 1 because it's y minus k, and the radius is 4. So these are all the important pieces of information. That means the center is at 4, negative 1. And it's 4 units away from the center because that's the radius. So let's get a coordinate system. And let's draw this. 4, negative 1 is going to be 1, 2, 3, 4, negative 1. So this right here is the center. Now all we have to do is draw something 4 units away from the center. If you were drawing this by hand, it's good to draw the endpoint. So we have 1, 2, 3, 4 units. That means this point is on the circle. We have 1, 2, 3, 4 units. 3, 4. This point's on the circle. 1, 2, 3. Extend this line out a little bit. 1, 2, 3, 4 units. This point's on the circle. 1, 2, 3, 4 units down here. This point is also on the circle. My graph, of course, is bad. That's why you don't graph by hand. But you can see if I can graph to get kind of the shape here. That's what the circle would look like for our for this guy. Okay, here I have the nice coordinate system on Desmos. So we're going to graph this circle on here. If we look at the circle, we should see that we have x plus 1, which means the center should be at right, it's supposed to be x minus h. Since we have plus 1 in there, that means h must be -1. And y here, this is the same thing as y minus 0, right? I could write it like this. Minus 0. That's the exact same thing as just y, which means k is going to be 0. So we should have -1, 0. That should be our center point there. And the radius, you see how I've written this whole process out. 8, the square root of 8 is going to be the radius. You can simplify this by seeing, you can do it with the factor tree like I did the last one, but you can see 8 has a perfect square in it, namely 4. So 8 is the same thing as 4 times 2. Then we can break up the radical over those two things. And the square root of 4 is 2. 2 times root 2. You can see all of these things equal 2.8284 and so on. So it's going to be about 2.8 units away from this center point. That should be our radius. We could find the endpoints by just saying -1 plus 2.8284, 0. The blue point there should be on the circle. Could do -1 minus 2.8284, 0. The green point should also be on the circle. And then you could, of course, add and subtract the top and bottom. But to actually graph the circle, we just plot it. And there we go. You see the blue and the green are both on the circle, and that red dot does indeed look like the center. Sometimes the equation of a circle isn't given in standard form, the x minus h squared plus y minus k squared equals r squared. We can get it into standard form by using what's called completion of the square. So this is a circle, and we can rewrite this in standard form by completing the square. The first thing I'm going to do is I'm going to rearrange this whole thing so that we have the x squared first, then the x, the y squared, then the y, and I'm going to add 3 to the other side of the equation. So I can rearrange this and it'll look like this. X squared minus 4x plus y squared plus 2y, and this equals 3. Now I can complete the square. This process can be confusing, but just take it step by step and you'll be good to go. The first step is to look at the variable here. That's the single variable, not the squared one. So for the x and for the y, we're going to look at them separately. We'll do it at the same time. So we look at the number in front of that, -4, and divide it by the number 2, always number 2. That gives us -2. Then we take -2 and square it. -2 squared is 4. Okay, for the green, we have 2 divided by the number 2. That gives us 1. 1 squared equals 1. Okay, so this number here is what we're going to add to both sides of the equations, and we're going to make sure they're lined up. The blue goes with the blue and the green goes with the green. So I'm going to add 4 right here, add 4 on this side. I'm going to add 1 right here, add 1 on this side. Now my equation looks like x squared minus 4x plus 4 plus y squared plus 2y plus 1. 3 plus 4 plus 1 is 8. All right, why did I do that? Because both this blue thing here and this green thing here now factor very nicely. And they will factor into whatever this number that you got here. All you have to do is just take x minus 2 squared. y plus 1 squared. This is a positive 1 here, since that was a positive 2. You can check to make sure of that by just foiling this thing out. X minus 2 squared, x minus 2 times x minus 2. Foil that thing out, you get x squared minus 2x plus 4, giving us x squared minus 4x plus 4, which is right there. That's the reason why we go through this process. It factors down nicely. Once you have that and you're convinced that you have the right things, you can always check your work here. The blue thing becomes x minus 2 squared, right? And the green thing becomes y plus 1 squared. And this equals 8. And now this is in standard form. The center is going to be at 2, negative 1, h and k. And the radius is at the square root of 8, which we just did. We just broke it down to 2 root 2. Okay, here's another one that we want to get in standard form. I'm going to rearrange this so that the x's and the y's are together. And now I can start looking at completion of the square. So for the blue, we have 6 over 2 is positive 3, and positive 3 squared is 9. So we're going to add this one, and we know when we do that, we're going to get the expression x plus 3 squared. This one goes right there. For the green, we have minus 8 over 2, gives us minus 4. Negative 4 squared gives us 16. We're going to add 16 to both sides. And when we do that, we're going to see that the y squared minus 8y plus 16, that's going to factor to y minus 4 squared. That is just plugged in right there. So I'm going to add 9, add 16. Okay, now we have x squared plus 6x plus 9 plus y squared minus 8y plus 16 equals 9 plus 16 is 25. All right, you can use the AC method if you want on x squared plus 6x plus 9. If you did that, you'd see that we have a times c is 9, b is 6. Two numbers that multiply to give 9, add to give 6 is going to be 3 and 3. Since a is 1 here, we have the shortcut method, namely x plus 3 times x plus 3. And this is the same thing as x plus 3 squared, which we already found right here. I'm just showing you a different way of proving that it actually does work. So for the y, we're just going to take it by faith. Y minus 4 squared equals 25. The center is at negative 3, 4, because it's going to be x minus h. So h must be negative 3 to get x plus 3. And then y minus k is 4. And the radius, you can say the center. The radius is at the square root of 25, which is 5. All right, one more. Let's rearrange this thing. I'm going to add 1 and move it around so that we have the x's and the y's together. Okay, now we can do the completion of the square. Negative 5 over 2 is going to be just negative 5 over 2. You could write it as negative 2.5. Fractions might be a little bit easier to work with, but we can just say negative 5 over 2. And negative 5 over 2 squared gives us 25 over 4. For the green, we have 3 divided by 2, which is, you could say 1.5 or just leave it as 3 over 2. 3 over 2 squared is 9 over 4. So we're going to add 25 over 4 to both sides. And add 9 over 4 to both sides. Right, we're adding this number. And we know we're going to get, I'm going to leave it as fractions and not use this negative 2.5, but this really is just negative 5 halves. We're going to get x minus 5 halves squared. And this one down here is going to be, it's just 3 over 2. Y plus 3 over 2 squared. That's because it's a positive and this one's a minus. So, okay, that gives us x squared minus 5x plus 25 over 4. Not yet. Plus y squared plus 3y plus 9 over 4. 1 is the same thing as 4 over 4. So 4 over 4 plus 25 over 4 plus 9 over 4. That's going to be 29 over 4 plus 9 over 4 is 38 over 4. This is going to be factored down, and this is going to be factored down. We get x minus 5 halves squared plus y plus 3 halves squared equals 3/8 over 4. The center, you can see, is at 5 halves comma negative 3 halves. The radius is at the square root of 38 over 4, which is the same thing as the square root of 38 over the square root of 4, which is the square root of 38 over 2. 38 is 2 times what? 2 times 19? 20 and 18, yep. And both of those are prime, so we cannot factor that any further. That's the best we're going to get. So I just want to convince you that the two things we got are the exact same. This first one is the original problem, x squared plus 3y plus y squared, all that. And that gives us this circle here if we just graph that. And the next one is blue. This is the completion of the square. This is what we found when we completed the square, and that gives us the exact same circle. You see they just overlap completely. So we have done it correctly when we completion of the square. When you have fractions, it makes it a little bit harder, but just do the arithmetic that you know with fractions, square it, square root it, all that stuff, and you should be good.